This is part 10 in a series of videos in which I'm attempting to develop a drop-in replacement for the cassette mechanism in a Fluke 9010A. If you've ever seen the inside of one of these, then this is the tape drive mechanism. It's obviously in a state of being dismantled here. I've been adding switches and the like so that I can more easily do this development. Gives me control over the various input lines. And what I've ended up with is the electronics now developed. This is working fine, just exactly as I want it. And it's going to save the internal memory from the Fluke into an EEPROM in exactly the same way that the Fluke saved data into a tape drive. It replaces the tape drive, can't really run it alongside a tape drive because the Fluke, it could probably be done, but with space limitations. And really the whole point of this is I find the tape drive very unreliable and tedious to use, so for me at least the idea is to use the memory unit instead. At this point I'd like to thank everyone that responded to my previous video and let me know they had one of these. I'm trying to figure out exactly how many of these are out in use. So far more than I thought. We're up to just over 60 units so far, so there are quite a few of these out there. If you do have one, then please let me know. One thing I haven't mentioned in the past, I keep saying that my channel is about the fundamentals of engineering, vintage electronics, this sort of thing. And one of the projects I have going at the moment is the ADM terminal that you may have seen videos for. If you are interested in that sort of electronics and you're not familiar with them, one place to look are the channels that deal with restoration and repair of arcade games. There are quite a few channels around with that, and they're extremely interesting if you're interested in that sort of electronics. Some very good channels and some very good content, and I think I'm subscribed to pretty much all of them. And a lot of those users will use a Fluke like this. But the nature of the electronics is very interesting, so it's well worth doing a search for that if you haven't seen them already. Okay, so on with the project. I have the electronics done, it's all ready, and incidentally the reason I'm using internal memory as well as a memory card is the way that I will probably use this. Everyone will be different of course, but the way I will most likely use this is I will have a separate card for each type of equipment that I repair. I work on a huge range of different machines and I use the Fluke quite a lot, but I'm quite often faced with the prospect of putting out the Fluke, spending 5 minutes entering a program because I can't be bothered to try and get the tape to behave itself, and then using the Fluke for the fault finding. And quite often what happens is I just can't be bothered to do that, so I'll use something else and use something that's perhaps not quite as suitable, and that's what this is really for. And the way I'll be using this, I suspect, is that when I switch to a different project, I'll put in the appropriate memory card that has the programs I want, read them, and then save those back to the internal memory on the unit, take the card out and put it back in its rack for safekeeping, just so I don't accidentally overwrite the card. If I accidentally overwrite the internal memory, of course, I can just put the card back in. So that's the way I suspect I will use it, and that's why I designed this with internal and external memory. But bear in mind that the internal memory replaces effectively 8 tapes, so it's 8 times 24K it can store, or sorry, 8 times 12K it can store, and the external cards will each replace 8 tapes as well, so there will be quite a decent capacity even if you decide not to use the memory cards. Having said that, I need a way to physically implement this unit, and that's what this video is about. The next step is to design the PCB, but it's often a mistake to design the PCB before you've sorted out the physical aspects of your design. And although I don't at this point intend to provide the physical mount for the board, I just intend to supply the boards, and it's up to the individual builder to implement the design in the way that they see fit. But having said that, I thought I'd present some ideas here as to what I intend to do, and see if there's any interest in that, and if anyone's got any more suitable alternatives. But to start with, we're trying to replace this, and as you can see, it's a bit of a monster as far as its physical configuration is concerned. So what we're going to end up with is a PCB about this size. This is just an offcut I've cut to the right shape and size based on the electronics and how big I know the board will need to be. But what we have to do is find some way to mount this unit to the inside of this case. So if we turn it over, it mounts in here of course. If we turn it over, what we have is a bit of an odd shape. There's no sort of square surfaces to measure from. These posts are different heights. This slopes, the entire case slopes, and then we have the cover which is normally fitted to the cassette drive, which is also not square. And what we have to try and do is find a way to mount all this as well as our board, and to have it look fairly neat and tidy. And there is of course a button that goes in here as well, which ideally we'd like to be able to refit to make the unit look fairly neat and tidy. So what we have to do is start doing some measurements. So it's grabbing the calipers and some pen and paper, and starting to do some sketches. So after half an hour or so with pen and paper, I had a vague idea as to what I wanted to design for my particular implementation. So we're going to have a look at the CAD system, and I'll show you what I intend to do for my installation, and then we'll look at trying to actually install it and see if it fits. Okay, so looking at the CAD system. So this is the drawing CAD system, not the PCB CAD system that you've seen me using previously. So this is a 3D drawing package. And so what I did is I measured the important parts of the Fluke molded case. And what I tried to do is create a design that would allow me to bolt in place something that would give me a proper mounting for the top cover. That's the clip-on cover that's normally attached to the cassette. A space to hold the button, but also a way to open and close the top cover, and also a way to mount the PCB. So if I just render this as a line drawing, you can see what I've ended up with here is a two-part design. So we have this lower base, we'll have a look at this in a few minutes, and then the opening part, and this opening part is the bit that the top cover of the Fluke clips onto. And what we end up with is something that, although it's a very odd shape, it fits in theory closely into the Fluke case. Now, one of the advantages in using a CAD system like this is that we can visualize what we're looking at, as well as accurately measure it and represent it, but also we can manipulate various parts of it. So for example, these two parts are in the closed position, but what I can do is effectively open one of the bits. So if I want to open the top cover, then I can do that, and it shows me now how it looks in the open position. More importantly, we can check that nothing's fouling, nothing's going to bind, and that there is all the clearance that we need there to be. And then we can obviously make sure it closes properly as well. So once I've got these parts drawn like this, then what I can do is select them individually, and then we can start actually turning them into CNC files that we can send to the 3D printer. So that's what I've done, and we'll have a look at some of the parts now, and I'll see if they actually fit into the Fluke. So as you can see, I went through a few prototypes, trying various ideas, and as I say, what I'm looking for is some way to mount the PCB and also this top cover, and if possible the button, into the top case of the Fluke in such a way that this will actually open. We need it to open so we can gain access to the memory cards and also to the dip switches that are used to select the particular memory bank. So after playing around with this for an hour or so and trying various things, what I ended up with is what we saw on the PC, which is this. I'll get these out of the way. So we end up with this, and this is exactly what we saw on the CAD system. The only difference is, of course, I've printed these off, and these in theory are now ready to fit into the Fluke itself. So before we try clipping the top cover on, when we open it, we have 3 holes, and these are for the 3 LEDs that I demonstrated on the unit to indicate the status of the unit. And then we have an opening here for the dip switches, so that we can actually access the dip switches to select the bank and the other options for the unit. Although I haven't put it on yet, there'll be a couple of bosses on the top moving cover, and that will allow me to bolt an edge connector on for the memory card, and the memory card will just plug into that, and then you can close it, and the Fluke will look just like it has the cassette tape in. So if it's the correct size, then this should fit into this opening, and get it right way around. This should fit into here, which it does, and then the board will fit onto the top of here. Then the screws go through the board. If I just fit one of them, you'll see what I mean. So they go through the board and then back into the original brass bushes that are inside the Fluke. So if we flip it over, then we'll see that what we have now is the movable cover, and in theory it should open. So what we'll try doing now is fitting the actual Fluke cover to it and see if it still fits in the Fluke outer case. Okay, so we'll pull this out of here. And again, if I've got my dimensions right, then this should just clip on. These slots are here because there are a couple of ribs on the underside of the cover. And the way this is arranged, there's a lip along the back edge of the top cover that fits into these 2 recesses. So that will clip over like this, and then in theory it should fit in exactly the same way that it did on the original tape drive. You need to be fairly careful with old plastic like this. It is fairly brittle, but as long as I've got this right, it should clip into place, which it does. And then what we have is a cover that will open and close, and as you can see, it stops at exactly the same point that the original tape drive did. And then of course we would get access to the switches, and we can see the LEDs. We can also add and remove the memory cards, which will plug in here, and then we can close it up. So we'll see if this still fits into the Fluke. So the button can also be fitted, doesn't really do anything, but it will fill the hole in and make it look complete. And then this unit fits back in here. And then of course the board would fit on the bottom like that, and the screws would go through and hold the whole thing in place. I'll flip it over so we can see it from the top. So as we can see, I need to raise the position of the button a little bit. It's 3mm too low, but I can easily do that. And then the idea is that we can open the top cover like we would with the cassette drive, put in the memory cards, get access to the dip switches if we can see the LEDs, and then of course we can just close the cover up. And it looks, to all intents and purposes, exactly as it did originally. In fact, this looks better than this did originally. For some reason this didn't line up properly with the original cassette before. So all I need to do now is, as I say, put a small addition to the moulding, the printed part underneath to hold the button higher, and then this is ready to accept the PCB. The pivot, by the way, is just a piece of polished brass rod, so that's extremely easy to fit. So as I say, that's the approach I'm taking. It means that the unit will look the way it did originally, and it's relatively easy to fit this. In fact, it's far easier to fit this than it is to fit and remove the original cassette. And as I say, this is just one idea as to how you could implement something like this, but obviously you could do whatever you want, fit it your own way, it doesn't really matter. The whole point is this is just whatever the particular builder prefers to do. So experiment as ever. Comments welcome, and please keep letting me know if you have one of these units if you haven't already.